Hello everyone, I am Vasant from ECB Batch B3. My team members are Vigneshwaran, Vinod and Pratap Raj. Today our topic is to discuss about design and implementation of multiplexer and demultiplexer using logic gates. Our aim is to design multiplexer and demultiplexer using the basic logic gates and verify the truth table. We are going to use the software Multisim to do the experiments. Here the components are AND gate IC7408. It needs two AND gates and OR gate IC7432, one OR gate, NOT gate 7404, one OR gate, and the indicators probe, digital switches, and power supply VCC. Multiplexer is a circuit which converts two power and informations into one a single output, which do power and input into single output with the help of n selection lines. Whereas demultiplexer is the reverse of multiplexer. It distributes one information, one input into two power and output lines using the same n select lines. Here the block diagram of multiplexer. The generalization of multiplexer is 2 power n is to 1, where 2 power n is the input lines and n is the number of select lines, where 1 is the single output. Here the block diagram is symbolizes a single output y, and here we are discussing about 4 is to 1 multiplexer, which means 2 power 2 cross 1 mux. It is shortly known as mux. Here the 4 input lines D0, D1, D2, D3 and 2 select lines S0, S1. Here S0 is LSB and S1 is MSB. Here the truth table. When both select lines S1 and S0 are 0, if we give D1, D0 as 1, which reflects, which transmits the input into the output. When S0 is 1, which means 0, 1, the decimal value of 1, which gives output as D1, which value are given. Then 10 decimal value 3, 10 decimal value 2, y reflects the output of D2, S1 and S0 1 decimal value 3, y reflects the output where the input D3 is given. Here the simplified truth table, which is known as functional table. S0, S0 both are 0 means it y gives D0, 0, 1 means D1, 1, 0 means D2, 1, 1 means D3. We are using K-map to simplify these expressions. Y gives input D0 when both S1 and S0 are 0. If only if D0 is given as high or low, it reflects its outputs. Multiplexer is also known as data selector, which selects based upon the select line's value. It selects which input is given to the output. It is also known as a rotatory switch function. Here Y gives high input when S0, S1 both are 0 and D0 is 1. Here we can see the K map for D0 when both S0 and S1 are 0 and only D0 is 1, we have output 1. So we are mapping that 1 in that place, which has a value of 1, 0, 0. Then by grouping, we have single 1 in this, which gives output of D0, S1 bar, S0 bar, because both are low. So we use complements symbol or bar. Like that, we using truth tables, all the relationships are derived from the K-map. Here the overall relationship between y because it is a data selector which is combined with both the 4 inputs, all the 4 inputs. When any one of the condition is true, it gives that input. So we will go to the multisim and simulate this circuit. Here the circuit for mux, it has two select lines S1, S0 and 4 inputs D0, D1, D2, D3 and a single output Y. It uses 8 AND gates and 3 OR gates. for the circuit. Now we will see the multisim file. Here the connections are given as per the circuit diagram. It has two select lines S1 and S0 and four inputs D3, D2, D1, D0 and a single IC package contains four AND gates. In the circuit we saw 8 AND gates, so we used two AND gate ICs 08082 ICs and 04 is a NOT gate, then 32 is OR gate. I can run. Initially I give both select lines as 0. When D1 D0 is 1, the output here visible is close. When change the logic to 0, it doesn't glow. Because when 00 means it selects the first D0 as the output. When I select 01, it gives the output as D0 D1, which state in D1, it gives that as output. When I change the state, it doesn't glow. When I give 10, it gives D2. We are able to change other outputs to check the condition, yet it doesn't affect the output. When I give both 1, it reflects the D3. When I give D3 as 0, it reflects 0. Here I can change all other outputs to cross check. Here the circuit is perfect. So this is the operation of 4:1 max. We may design up to 2 power n is to 1 max. So here possible to design 8 is to 1 max and so on. Here the block diagram for demultiplexer is given. Demultiplexer is generalized as 1 is to 2 power n, where 1 is the single input and 2 it has 2 power n outputs and n select lines. It is the reverse of the multiplexer, where multiplexer is a data selector, demultiplexer is a data distributor. Here the truth table, we can see the input when and only it has high state, then only it reflects the output. Here 00 means D0. When and only X is high, it reflects D0 as 1. 0 means it reflects 0. Here the input X is also known as enable. We can simplify the truth table by K-map as we saw in the multiplexer. So we directly go into circuit. Here the debug circuit has two select lines S0 and S1 and an input or enable pin, and it has four outputs D0, D1, D2, D3. Now we can saw the simulation. Here the circuit for 1:4 debug. I have designed for 1:4. You may get design 1:8 and so on. First, when I gave S1 and S0 at 0, when enable is high, it distributes the inputs to D0. When I change enable, when I change the enable, the D0 it doesn't glow. Here you can see that I can change 01 D1 glows, 10 D2 glows, 11 D3 glows. When the enable is high, if the enable is not high, it's low. Any of the outputs doesn't glow. Okay, friends, thank you.